I would like to thank the AFPM and Christina McDowell for allowing SEI to make this visual presentation. SEI Incorporated has been in business since 1986, and I joined them in 1988. The PowerPoint has been set up in 5 sections. It has 21 slides. If any questions, please record the slide number and wait for the question and answer session at the end of the presentation. SEI manufactures 2 products, basically boiler watch MMP2 acoustic pyrometer that uses the ideal gas law to provide exact gas temperature information for the refinery or petrochemical heater. We also manufacture burner watch, which is an acoustic flame detector, and profiling. Both use similar hardware. Our involvement in the refinery sector started overseas in Aruba and Curaçao, 2001 and on, where there are 2 refineries, Coastal Valero, which is now closed, and Shell PDVSA. SEI Incorporated was allowed to install and test in all of their furnaces. This resulted in the fact that the NPRA, through CITCO, resulted in the paper that we are now presenting. Currently, we have many installations overseas and many reports. We have uploaded into YouTube an introduction video, which is about 5 minutes in length. At your leisure, please go ahead for you to review the YouTube video for you to have a basic understanding as to how our technology works. Thank you. The most important aspect of the acoustic pyrometer, this novel technology, is that it actually does measure gas temperature. In the early 1990s, our installation at Turkey Point, Units 1 and 2, Douglas Hilleman, the maintenance manager, decided to verify the gas temperatures, and that is the report that he made a few years back. Also in Italy, after our installation in a coal power plant of 660 megawatts, the government was interested in verifying that our isothermal maps as well as our area maps did confirm real temperatures, and we do have a report on this suction pyrometer that was used. This is very interesting because the worst thing that can happen is that you have an incorrect gas temperature indication and that we do cause a problem in a refinery. One of our most important installations is in PDVSA, where with a Rockwell control logics, we actually control the fuel coming into the refinery heater. This is very important because in order to maintain high efficiencies, you must be able to control all the variables like the stack damper and ambient air, which affects the combustion. Here you can see we have 4 refinery heaters. We have 4 PLCs. We supply the Honeywell TDS 3000 with the information. At the same time, we split information from the gas temperature and we supply to the Rockwell's PLC so that it can actually monitor and control the fuel injection to the burners. This was done in the late 2007-2009 at the Cardón refinery in Venezuela. In this slide, please read so that our technology can be better understood. In this slide, we show 3 main components The external mounted sensors, up to 16 sensors, 24 paths, mounting on 4, 3, or 2 walls, depending on the furnace. Item number 2, the PCU controls the air valve, which is the only moving part, supplies AC or DC volts for the valve, and 24 volts to the preamplifier. Calculates the temperature. The mapping computer today, we can export to smartphones and big screens. This slide shows how the transceiver's red emitting broadband sound, cleaning and cooling. Receiving sensors are green. Sound, the delay in milliseconds is calculated with the ideal gas law, and with the known path length, true gas temperature can be calculated. Note that the paths cover the furnace with temperature lines with many intersections for a realistic two-dimensional temperature depiction. Wall temperatures are provided with our software. For verification of temperatures, we use an HVT, the only way to be assured correct temperatures. The slide explains the details of the sensor. Air valve is the only moving part. Venturi creates the shock wave, reduces airflow since it is only a 4/10 of an inch opening. Sound is deflected at 90 degrees. Microphone detects the sound signal, and the sets time as T0 for transmitter. As soon as the sound is detected by the receiver, T1, we calculate the time en route and calculate the temperatures using the ideal gas law. Very simple, non-contact, and low maintenance. Here are the 4 most common screens in our software. Upper left, mapping, two-dimensional temperature distribution. Lower left, area map, up to 24 areas, any size or orientation. Upper right, path plot or temperature plot. Lower right, trending, balance or unbalanced furnace. Here you can appreciate a horizontal isothermal map. 8 sensors, 4 wall, floor burners. Sensor location 2/3 above the floor of the heater. This assures complete combustion for achieving low emissions. Take note of the progression. On the upper right, you may see trajectory map. And from the trajectory map, we draw the isothermal map. And from the isothermal map, we draw the area map, which is color-coded, that shows temperatures which are maybe high, on target, or low. These are user adjustable. Here you see 2 vertical maps, which is normally in a reformer. 9 paths per map. Sensors in this case are mounted on the observation doors. The isothermal map will indicate combustion balance or unbalance. The area map shows color-coded temperatures. This information is sent to the DCS via OPC. Please read this text. It will basically give you information of our technology and why it has tremendous value for the refiners. This slide shows on the left side flame impingement caused by faulty air distribution in a fossil fuel boiler. As you can see, it affects combustion. The right side is the same furnace where through adjustments of the air damper, we were able to balance the combustion. This process, as you can see in the center of the combustion, is ideal. This slide shows 3 thermal maps as we were optimizing the combustion. Note the time and the efficiency. At 8:30 in the morning, you can see no isothermal center of combustion, and the average is 87.83%. Note that at 9 o'clock in the morning, top right, we see that a small formation of a hot spot, and basically the efficiency is going to 89.08. Bottom left, you can see very balanced combustion, and this results after 1 hour and 10 minutes of balancing an efficiency of 89.58%. This is basically a boiler with 21 trajectories, 2 sensors in the front walls, and on lateral walls we have 3 sensors per wall. It's an excellent installation. This slide shows 2 isothermal maps in a delay coker, a very large delay coker in China. Here you can see how we optimize the combustion. Note that at 10:58 we had a delta T of 207 degrees Celsius. You can see the ball of fire on the right side of the isothermal map. Since it's such a large furnace, basically a few hours later at 13:33 we were able to reduce the delta T to 43 degrees Celsius. You can see it's a very, very well balanced delay coker furnace. Here you may see the delay coker in China. You can see the 4 external sensors on the side wall, and you can also see the openings that were used for mounting our sensors on the ends and on the sides of the furnace. This graph is showing temperatures, area trending in a crude heater. Adjustments in the stack and air registers are evident. See how it affects the combustion. This report, The Sound of Temperature 2002, created by the student Mr. Jesus M. Duarte for Fontes Hogeschool Applied Sciences in Holland for the engineering department. He was assigned the study of the acoustic pyrometer that was installed in the refinery of PDVSA Shell. You can see the first unbalances in the area, air register adjustments to balance. Then we see that because we had to increase the production, we resulted in a unbalanced heater. Note balancing by air registers again in green. Here you can see the increase of efficiency in our installation in an oleofin furnace. Take note that after all the adjustments, we were able to obtain a 2.8% increase in throughput. This is for an ethylene reformer. Thank you for allowing me to share our overseas experience. And if you require that I go, or Stephen Mattis, which is a representative for the Southeast, if you want us to visit your refinery, please don't hesitate to give us a call. Thank you very much and be safe.